Next, let's look at random experiment 2. We roll a die, or we flip a die twice. In a die, this is a 6-sided die. You're going to see spot 1, spot 2, all the way up to spot 6. This is also a random experiment. Why this is a random experiment? When we roll a die twice, there are many possible outcomes. There are many possible outcomes. For example, I can see spot 1. Spot 1 on the first row, and then see spot, say, 3 on the second row. And in this picture, on the first row I see spot 2, and second row I see spot 5. So, which, as we can see, already has what? 2 possible outcomes. So we actually need to roll the die twice to see which outcome we get. Okay? Actually, when we roll a die twice, how many possible outcomes are we going to see? Well, there will be what? 36 possible outcomes. Okay? Now let's look at random experiment 3. Let's look at random experiment 3. Suppose we close our eyes and randomly pick up a point from what? 0, 1 interval. This is a random experiment. We randomly select a point from the interval. So any point between 0 and 1 can be selected. And how many points are there between 0 and 1? Infinitely many points. So we should actually what? Do it to see which one we see. Okay? So this is also a random experiment. Now, next one, let's define a sample space. Let's define a sample space. What is a sample space? What is a sample space? It's the collection of all possible outcomes resulting from a given random experiment. Okay? For example, the sample space of random experiment 1. Okay, the sample space of random experiment 1, denoted by S sub 1. Okay, when we flip a failed coin 2 times, there are 4 possible outcomes, namely head-head, tail-head, head-tail, and tail-tail. So, number of possible outcomes in sample space 1 is 4. Okay, number of possible outcomes in sample space 1 is 4. Next, let's look at K-tuple notation. Let's look at K-tuple notation. K-tuple notation, where K is what? A positive integer, greater or equal to 2. A 2-tuple, for example. A 2-tuple is what? We put in what? A 2-tuple. The first position in the 2-tuple, we denote what is the outcome resulting from first trial. Second position in the 2-tuple, we put down what? Outcome from what? Second trial. Note that when tuple notation are used, order matters. For example, when we flip a failed coin 2 times, we consider head-tail is not the same outcome as what? Tail-head. This one is the first time we see a head. This one is on the second flip we see a head. Order matters. So these two are considered 2 different outcomes. Okay? Now, next one, let's look at what? The sample space. Let's look at the sample space. The sample space of random experiment 2. Okay? The sample space of random experiment 2, denoted by S2 or S sub 2. Okay? Let's see, how many outcomes are there in sample space 2? Well, random experiment 2 is we roll a balanced die 2 times. Okay? So we can see 1, 1. First time we see a spot 1, second row we see spot 1 again, okay? Now this one is on the first row we see spot 1, second row we see spot 2. This one, on the first row we see spot 4, second row we see what? Spot 3, okay? All together, we find what? There are 36 possible outcomes are there in the sample space. And we use notation like this. Okay, we use this kind of notation. The sample space, okay? How many possible outcomes are there in sample space 2? Well, there are 36 possible outcomes. This is a cardinality of what? S2, okay? The cardinality of S2. Now, the sample space of random experiment 3 denoted by S sub 3. We use a mathematical notation. We say X is any real number that is between 0 and 1, okay? We use X to denote what? To denote the selected point. How many possible outcomes in S3? Well, the answer is what? Infinitely many. This notation is what? Infinitely many, okay? Comments. There are uncountable many possible values in S3. So X, the selected number, is a continuous what? Variable, okay? It's not discrete. Discrete means possible value are countable. In this case, possible value are not countable. So it's what? It's a continuous variable, okay?